So for those of you who weren't in the last session, my name's Mike Anderson, and I'm Chief Scientist for the PTR Group. PTR Group, we've been around now since 2000. We have a lot of different areas of work that we're involved in. We do a lot of work for on robotics. We do work for NASA. We built a new platform where the folks that are doing the embedded software for a new project that NASA has, where they'll have a satellite will come up and grapple another satellite, unscrew the filler cap and refuel it in orbit. And the tricky part of that is it has to all be done autonomously, because the delay, the radio delay to get to geosynchronous orbit, that's 24,000 miles. The radio delay is about 1.2 seconds. So you can't control it, even from the space station. The space station is too far away to have a human in control. So the robot has to be completely autonomous, which is an interesting problem. So we've done a lot of work with flight software. We have about 35 satellites on orbit right now. We do a lot of work for Orbcomm, and of course Orbcomm has had their problems with SpaceX. If you're familiar with SpaceX, the company that keeps blowing rockets up, not that they mean to do that. It's totally not their fault. But the reality is that we've lost 3 satellites thanks to SpaceX. So in any case, the last one though, they got 11 satellites in orbit. So we actually managed to get 11 satellites in our constellation. So we're happy for the moment. All right, so we do flight software, as I said. We do that for Navy Research Lab and for NASA and several others. We do both offensive and defensive cyber operations. And then we do embedded software ports for Linux, bare machines, bare metal stuff. So a lot of IoT architecture and deployment stuff coming into play right now, because people are starting to realize that the Internet of Things is not like just plain old Linux. There are several different components of the Internet of Things that we'll talk about in this session. Myself, I've been in the industry now for about 39 years. I developed part of VxWorks. I worked on the 68K, the i960, and the PowerPC releases of VxWorks. I'm an instructor. I do a lot of work with Linux and Android. My company teaches Cisco how to do networking. So we teach their engineers how to work with Linux, how to do device drivers, how to work with IPv6 and things of that sort. We also, I've presented at a lot of different places, including CIA's Emerging Technologies Conference, where the primary focus was the Internet of Things. Now, interestingly enough, so when you talk about security and you talk about the Internet of Things, we have, for instance, refrigerators now that have RFID scanners on them. So one of the major things that's happening with our good friends at Walmart is on the path right now to switch over to a consignment model. Now, what that means is they no longer hold inventory. They only have something on consignment to sell. So if you're the manufacturer of Samsung's television sets, they will basically lease you wall space to sell your television set. And if you don't sell it, that's not their problem. They will simply put it back in the box and ship it back to you, and it becomes unusable inventory. You can't sell it as new because it's been out of the box. So it's an interesting set of problems that's happening there. So one of the things we were talking about was, let's say you have a refrigerator that, as they start switching over to this consignment model, they are forcing everybody to go to RFID. So let's say you have a refrigerator that has now the milk that you buy has an RFID tag on it, and therefore the refrigerator can tell how much milk it was, what its expiration date is, and then the question becomes, will you allow the refrigerator to reorder milk when your milk expires? I put this question to the folks at CIA, and I go, well, so we have a room here of people who understand security issues, and let's say that I'm Giant Peapod, and I'm willing to give you a 5% discount if you will allow your refrigerator to automatically order your groceries for you. Would you do that? And the answer is no, absolutely not. Okay, 10%. Nope, sorry. 15%. Probably not. 18%. Well, for 18%, probably would. And I go, okay, so now we've just established that this room filled with security professionals who should know better have a price, and it's just a question of negotiation. That's the issue with the IoT. And when we talk about these projects and these different platforms, we have to think in terms of what is the impact of this platform? What is its revenue model? Where do we believe that we're actually going to be able to get recurring revenue? The reality is that you only get in this business if you think you're going to make money at it. Very few people are into the IoT for their own, well-being of the country or the world or whatever. So the question is, when you talk about a platform, what exactly is a platform? And unfortunately, it depends on who you talk to. So we'll talk about platforms and the architectures associated with those platforms. We'll get into the big players in the platform wars, and then how we go about differentiating between consumer Internet of Things and industrial Internet of Things. When we talk about where the money is really in the industrial and medical side, not in the consumer side of the IoT. So when a lot of people think about the IoT, they immediately think Fitbits and CrossFit trainers and things of that sort. The reality is there's no money in that, at least not recurring revenue. You buy a Fitbit. You might buy 2 Fitbits if the first one breaks. But after you buy the second one, you go, okay, if it breaks, well, I'm not going to buy a third one. So there's really no recurring revenue in that kind of a model. So you have to continue to expand the marketplace in order to be able to continue to capture market share. So it's kind of a tough problem, and I speak at a lot of IoT conferences around the world, and unfortunately right now what we see in most of the IoT conferences is it's still primarily suits getting up there talking about what the market model is. So they're still primarily talking not about the technical implementation of the IoT, but whether or not there's a revenue model that makes the IoT actually function. And I have a friend of mine, he's the Deputy Director of Cyber Physical Systems at NIST in Maryland, and we were talking, and he goes, he is into smart cities and anything to do with smart cities. And smart cities sounds like a really cool thing, but every time I meet him, he says, have you figured out what the revenue model is yet? And the answer is no one has. The only revenue model that seems to work in smart cities at the moment is parking, where they outsource the parking to somebody. But that's about it. There really hasn't been any significant change in the smart cities world that gives you the idea that there's really going to be any money in it. Now, there's some good points where, for instance, I think Barcelona managed to save $10 million a year in garbage collection because they put a sensor in the garbage can that tells you whether or not it's full. And if it's full, they'll have this truck stop, and if it isn't, they won't, and that somehow saves them money. And that's great. I mean, that's a fantastic approach. But, garbage cans and parking, what other models are there? We haven't figured it out yet. I'm sure there are some. We just haven't figured it out yet. So what exactly is the Internet of Things? Well, of course, a thing is any device that's got connectivity to the network these days. Now, we used to think in terms of a refrigerator being a dumb refrigerator. There was no intelligence associated with that. Your toaster didn't have any intelligence associated with it. Basically, these were all relatively dumb devices. But today, anything that we can hook up a microprocessor to can basically be made to be intelligent. I have seen an internet toaster. It does, in fact, download JPEGs off of the internet and then uses an inkjet-like material approach to burn the toast and burn the picture into the toast. Now, of course, that means that the market for grilled cheese sandwiches that look like the Madonna has just plummeted. There's just no market in that anymore. It's really completely trashed that marketplace. But, I mean, again, okay, yes, you can do some really strange things with the Internet of Things. The question is, should you, or why would you? And is there a way for you to be able to make money at it? That's a different question. The data that's produced from these things has to go someplace. It could be that it's just totally consumed locally. Maybe it's in the thermostat. Your Nest thermostat, it's just telling you what the temperature is, and maybe that's all it does. But the reality is that in many cases, we're really focused on trying to get that data to some place to do data analytics. And this is where the cloud comes into play. And there are really two significant models that we have to play with in the IoT. The first is the cloud model, where all of the sensors are directly connected to the internet. And that's the one, if you talk to most people, when they think about the Internet of Things, that's the thing they think about. I have a bunch of sensors, and these sensors are going to talk directly to the server, and the server is going to somehow figure out something really useful out of that, because I've got data scientists that will look at the data, and they will derive some piece of wisdom from it, and we'll be able to make things work better. The problem with that model is that every single sensor is now exposed to the internet. And that means that every single sensor becomes your attack surface. And from a security perspective, that's a huge attack surface. And that's not something that, when I work with my customers, I say, look, okay, the other model is the fog model. And in the fog model, that means that your sensors only talk to the border gateways. They don't talk all the way up to the cloud. The border gateways collect the data, they collate the data, they then send a compressed version of the data up to the cloud. And first of all, that saves you, especially if you're using things like LTE, that saves you communications costs. And it means that the only thing that's really exposed to the internet with a capital I are the border gateways. And the border gateways tend to be Linux-based systems where we can actually secure Linux using a couple of things we'll talk about on Wednesday when we get into how you secure an embedded Linux platform. So the advantage that we have with the fog model is we are limiting the size of the attack surface. And there are some other things that we have to do in the fog model for the border gateways to also limit the size of the attack surface for those as well. But there are a lot of issues that go along with security, and unfortunately we don't have enough time to get into that in this particular session. The core of the IoT is really a way of getting access to that sensor data and potentially controlling devices based on that sensor data. When we talk about the industrial Internet of Things and process control and using sensors inside of large-scale, either power production, things of that sort, I had an opportunity to speak at a conference on the use of the smart grid and where the smart grid is at this point and how it's changing. And we're seeing that in many cases, the big problem is legacy equipment. When you're in the industrial world, you have RS-232, RS-422, 423. You may have 449 sitting out there. You may have 20 milliamp current loop. I mean, these are all old standards that the industrial world still uses on a daily basis. So when I bring in my fancy pants brand new sensor and they go, okay, so where's the RS-232 port on it? And you go, well, it doesn't have one. They go, well, okay, it doesn't work for me. Sorry, get out of here. It's a different sort of model that we have to understand that the legacy side of the Internet of Things, the industrial Internet of Things, is a significant problem. We have to figure out a way to solve that. And in many cases, it's putting special level shifters and things of that sort on it so that we can actually get to those voltages. Of course, the data, what you do with the data is the real piece of this puzzle. Personal consumption, things like Fitbits and fitness bands and that kind of stuff, okay, that's nice. But the real money comes from SCADA, supervisory control and data acquisition. It comes from industrial process control. It comes from being able to use this in oil refineries. I mean, this is where the real money for the industrial Internet of Things comes from. And this is the market that's basically estimated to be about $3 trillion in sales by the year 2020. I mean, that's not very far off. And it is expected to be 3 times the size of the consumer Internet of Things. So the consumer side is really not all that much. It's $1 trillion. That's a lot of money. I'd love to have a couple of percentage of that. But the reality is that from a manufacturer's perspective, there's really not a whole lot of recurring revenue that comes out of that particular model. Because when we get into some of these platforms, we're actually focusing on what they focus on. They focus on recurring revenue. How do they get month-to-month payments from you for providing you these services that are in their platform? So that's kind of the key piece that we'll talk about here in a moment. So what is a platform? And it depends on who you talk to. There are so many different definitions for platforms. It's really kind of silly. Some people will say it's a piece of hardware with sensors. That's a platform. I'll sell you my sensor platform. And it's really just a MEMS sensor. It's got, it's got accelerometers and gyroscopes and a digital compass in it, and that's their platform. Okay, that's certainly one piece of a platform, but I wouldn't necessarily say that's the whole platform. But if you look at their advertising, that's what they claim to be their platform. We can have an operating system that's targeted at a particular sensor technology. We see a lot of those specialty OSs that are starting to come out right now. And they are claiming to be a platform that then enables a whole bunch of underlying hardware. We have communications protocols claimed to be platforms. It uses CoAP, it uses RESTful, it uses MQTT, and all of the alphabet soup that goes along with that. And then, of course, we have end-to-end systems that are then going to connect the sensor up to the cloud so that the cloud people can then provide data analytics. So which of these things is a platform? Well, again, it depends on who you talk to and what you're trying to sell, because whatever it is you're trying to sell then becomes your platform, right? All right, so at some level, it's all of these things. Now, for the consumer Internet of Things, it really breaks out into two pieces. We have fitness-related devices, your wearables, your exercise equipment, those kinds of things. And believe me, I was at Consumer Electronics Show in January, and they had the entire Sands Hotel Convention Center dedicated to fitness stuff. And you go, wow, okay. I'm not saying there isn't money in it. The question is, how many of them do you sell to a single individual? You know, once you sell that treadmill that keeps track of how far they've walked, or adjusts itself based on they're walking through San Francisco and it adjusts itself based on whether they're going up a hill or down a hill. After you get past that first sale, how much do you really get beyond that? But the other piece of this, which is really the place where most of these IoT platforms are kind of focusing, is in the home monitoring business. Now, we used to call this home automation, and home automation never sold. Nobody was interested in home automation because they didn't really care about automating their home. However, they are interested in monitoring their home. They want to know if the door is open. They want to know if the air conditioner is on. They want to know if there's a camera, if the camera is on and who just came in through the door. Oh, it's the kids. They've just come home. Okay, I want to know that. This is the kind of thing we're talking about when we talk about home monitoring. And home monitoring is where we see things like Thread and Apple's Homekit and those pieces, which we're going to talk about here coming up. The fitness market is relatively new. It's going to be battery-powered sensors for the most part. We'll see Bluetooth, NFC, Wi-Fi, in some cases USB connectivity, dominated by proprietary solutions. You can buy Garmin's system, and Garmin's system isn't compatible with Fitbit, and Runtastic's system isn't compatible with Garmin. So all of these environments, because it's one manufacturer, it's its own little walled-off garden, it all works amongst the same manufacturer, which of course gets that brand loyalty that causes you to come back and hopefully get some recurring revenue for them as you buy additional devices to enhance the fitness environment that you're working in. I know my wife, she just ran a marathon in Asheville, North Carolina, and she had originally started with Fitbits, and they didn't do what she wanted it to do. She had an Apple Watch, and that quite didn't do the thing either. And then she ended up buying into Garmin, and I shuddered to think how much money she spent on all the Garmin pieces that she had to have in order to run her marathon. But I know it was expensive. Now, in the consumer Internet of Things, this is where we see the major players: the Thread Group, HomeKit, Zigbee Alliance, Z-Wave Alliance, IoTivity, Allseen Alliance. All of these are manufacturers that are looking at this kind of low-hanging fruit, if you will, of consumer home monitoring type services where it doesn't have to be in an industrial environment. It can be powered off of the wall all the time. You know, you're not running that Nest thermostat off of a battery 24/7 for however long you want to run it. All of those kinds of things, we can use bigger amounts of power. We can have Wi-Fi interfaces. All of these kinds of things make it easier for the consumer to be able to deal with the device. Now, interoperability here is going to be the key. And this is where most of the platform vendors really start to step up. We see that the IoT can really be thought of in three different ecosystems. We have the edge ecosystem. This is where they have the small sensors, the actual devices, the smoke detectors, and things of that sort. We have the middle ecosystem. These are the border gateways, the border routers. These are the devices that are going out here, and they may be Linux-based. They're collecting data. They're implementing the fog model. All of these types of devices, they're typically powered all the time, although not all of them. But in many cases, they're going to be constantly powered, and they represent a different, completely different style of environment to work in than we have at the far edge. We have then, of course, the cloud side. Now, on the cloud side, all bets are off. It's big, tall buildings with no windows and lots of air conditioning in the back with, security devices and fingerprint readers and everything. So security in that kind of a world is a different sort of thing than what we would see in the middle box or the edge devices. When we have consumer edge devices, they may have wall power, in which case we can pretty much run any operating system, any kind of platform we want to in those kinds of environments because they have constant power. We don't really have to worry too much about size, weight, and power concerns. We don't have to run off of a 2032 coin cell for 10 years on those types of devices. So the middle boxes, of course, they're the border gateways. These are the devices that are going to be doing the translation from 6LoWPAN, from Zigbee, Z-Wave, into something that's going to go out on the internet. Maybe it's going to be IPv4, maybe it's IPv6. The cloud portion, of course, is also where we see the connectivity that comes back to the controllers that are used for command and control. So if you've got a smartphone, a tablet, and it's interfacing into the cloud, and the cloud is providing you live data, you can then say, well, look, these 40 acres over here in this farm, it's too dry. Let me turn on the sprinklers. But here in California, that turning on the sprinklers, that's a big deal because water is like gold out here. So as a consequence, having that hacked and having somebody be able to arbitrarily turn on the sprinklers and burn up a lot of money because you're overwatering the farm, that's a big problem. So data aggregation and data analytics, of course, connectivity and the data services. This is where the data scientists live. The edge devices, as I mentioned, they are the things where we've got legacy equipment, RS-232, 485, RS-170 video, industrial kinds of applications. Now, typically we'll see those using much lower power connectivity. We'll see using Bluetooth, NFC, 802.15.4, and similar sorts of protocols. Now, that's just at the communications layer, layer 1, layer 2, and layer 3 typically. Then we'll set a stack on top of that. So we'll see layer 4, we'll see 6LoWPAN, we'll see Zigbee, Z-Wave, those kinds of things at layer 4. And then you have the things that are coming down from the top, where we saw, for instance, the talk this morning, the keynote talk about where IoT fits into the grand scheme of things and how it comes down from the top and then sits on top of some of these other communications protocols. So the thing we have to understand is that the world at the edge device, the actual sensor itself, is this incredibly small processor that looks a lot like it did back in 1995. We've got 32 kbytes of RAM, 128 kbytes worth of flash. It runs 48 megahertz, maybe, but it has to be able to run off of a battery for 5 years. So that's an interesting problem. Now, some of this, the manufacturers of a lot of the silicon have actually gone out of their way to enable you to run bare metal. Realistically, for radios, I asked the Chinese manufacturer, at what point does it make sense to make your own radio? The answer was 1 million units. If you can't sell at least 1 million units, you're better off to buy an already existing radio from somebody. And there are a lot of them out there. Texas Instruments sells them, Nordic Semiconductor sells them. All these different manufacturers will sell you a radio, and this radio has the protocol built into it. It's got IP, it's got UDP, it's got TLS, it's got DTLS. It's already got the protocol stack in it, so you don't have to implement that in your sensor. Your sensor can be bare metal, no RTOS, nothing. Basically, it sits there and runs the sensor, wakes up every 24 hours, runs the sensor, figures out what the values are, and then shoots it up the radio. The radio interface, SPI, I2C, UART, period. You're done. You don't have to get any further than that. So when people talk about, oh, well, but I need to get UDP sitting on my sensor. Not really. You just need to get UDP to the radio, and then you use the radio to do that. So they've really done, I mean, the manufacturers of Texas Instruments and Freescale and those guys have really done, or NXP, I guess, these days, and Intel. Intel has a really nice, cool little IoT gateway box that talks to all these low-end sensors. So, you know, there are operating systems out there, VxWorks, and of course, RTOSs like FreeRTOS and Contiki. All of these are targeting these small platforms. Now, the question you have to ask when you're building a sensor in the Internet of Things, do you really need an operating system? Some people will just put an RTOS on there as a matter of course, but realize that RTOS now becomes another attack surface. If I know you're using VxWorks 5.5 and there's a vulnerability in VxWorks 5.5, of which there are several, then I know how to attack you. And the key thing is that the hackers today are not typically your script kiddies. They're not people that just simply find a toolkit and they turn it loose on the world. A lot of the hackers today, they're professionals. They're in it to do ransomware. They're in it to make money somehow. And so if they can figure out a way to, hey, if you don't pay me money, I'm going to shut your sensor network down, okay, you're going to end up paying them money because they've somehow taken control over your sensors. So in this particular segment, C and C++ becomes the dominant language. There has been a version of MicroPython that was created specifically for the STM32 micros. That's a Cortex M4, but that's kind of a rarity. When we talk about things like Java, typically you talk at least a megabyte of RAM in order to run just the VM. And when you say that, okay, all of my schools these days, the universities are producing people who think everything is a virtual machine. And they've been taught that they can have essentially infinite memory, infinite storage, infinite CPU cycles, because that's effectively what the PC has. So when you're trying to do development for the IoT, and your engineers only speak Java, or they only understand how the virtual machine environment runs, then when they start getting down to this bare metal, where they're starting to do things in assembly language in C and C++, they're lost. And this is another problem that we have that's going to be a major problem. As we saw in the keynote, we saw how many developers were actually embedded developers. There was like 600K embedded developers, but there's 9 million Android developers. Well, that's all very fine and good. That might work on the middle boxes. Probably not going to work on the far edge devices when we're talking these very small processors. The border routers, of course, here's a Raspberry Pi that happens to have 802.15.4. These are going to be running MMU-based operating systems. We've got plenty of memory. Memory, relatively speaking, when they talk about things like, it only has a gigabyte of RAM. And for those of us who started development back in the 80s, a gigabyte of RAM is just inconceivable. So, and people complain, it only has 256 megabytes of RAM. It's like, that's a lot of RAM. You can do a lot with 256 megs. But it's just the difference in the viewpoint on how the developers are being trained these days at the university level, and what does that mean once they get into industry and they start actually trying to build things like these Internet of Things devices. And a lot of these border routers may also take the form of GUI-full devices. Now, GUI-full devices are smartphones and tablets and things that have a nice picture GUI on it, and you can then swipe and provision things and things of that sort. But understand that even when we talk about the border routers, these are relatively small machines. These are not machines that have 64 gigabytes of RAM. They might have 256 megs of RAM. That's a lot in comparison to the edge, but it's not a lot in comparison to large servers, which a lot of these folks are used to dealing with in Python and JavaScript and C++, of course, Java as well. So the cloud, all bets are off in the cloud. It basically multi-core x86, multi-core ARM. We're starting to see a lot of ARM come online at this point. And the issue is that, of course, Intel working very diligently at trying to cut the power consumption of their devices. They have to do that because if you look at the cost of a data center, 80% of the cost of the data center is power and cooling. The other 20% is the equipment and the people. So realistically, if you can cut the power consumption by 30%, that's a big deal. In 2012, data centers consumed 12% of the entire U.S. grid. 12% of the entire power production of the U.S. grid in data centers. That's insane. That something has to be done about that. And that's where we start seeing a lot of this stuff changing, focusing much more on low power processors, even though I may need more of them. What do you know about your application? If you're running an application in the cloud, what do you know about the device you're running on? It speaks HTML. That's all you know. Is it ARM? Is it x86? Is it what? We don't know. We don't really care. As long as it does the job and does it in the speed with the speed that we need, we don't care. Now, we throw, especially in these big data centers, they throw around the concept of a petabyte. And they just kind of say, oh yeah, well, it's a petabyte of storage. To give you some perspective, these are Facebook's cold storage. So all of that stuff that you thought you deleted off your Facebook account, no, it's there. And each one of these racks has 1.94 petabytes of storage, and each one of those racks weighs 20 tons. That's a lot of weight right there. That's 60 tons worth of disk storage. Obviously, I hope they have it on a very good floor. But, just in comparison, a petabyte, if we had 1 byte was a grain of rice, well, a petabyte would cover all of Manhattan. It's a pretty big deal. And now they're talking about moving to exabyte storage. That's huge. And it's because the data, the raw data coming from the IoT sensors is just being shipped up into the cloud, and they're hoping that they'll be able to figure out something by looking at the raw data. And that's one of the reasons why a lot of these manufacturers, a lot of the platform vendors, don't want to go to the fog model. Because first of all, it cuts down the amount of communications costs. Secondly, it cuts down the amount of data that they're storing, and they're billing you for the data. They're billing you for the communications in some cases. So they really don't want you to do any data aggregation at the edge. They really want you to send all that raw data up. And of course, there's another argument that says maybe there's something in the raw data that would get filtered out by the aggregation that they wouldn't be able to then see, and therefore it wouldn't be as useful to you. So the message protocols here is a real alphabet soup, unfortunately. We have MQTT. This is one of the more popular ones. It is a publish-subscribe type protocol. Can sit on top of TCP for message reliability. Focus, though, is telemetry gathering. We have XMPP. That is Facebook and Jabber use XMPP. But it's XML format across either HTTP or TCP. Again, a lot of the issues that we run into, even when we start talking about RESTful protocols are HTTP get and put commands. Now, that might make a lot of sense for somebody who speaks web, but from a data perspective, from somebody who's actually producing data at the edge, that's insane. That's ASCII. XML? Are you kidding me? I'm going to be sending XML messages across the network? That's going to triple the amount of data that I'm going to use. Just because you can't use a more cohesive protocol, that's where things like CoAP come into play. CoAP is basically like RESTful, but it's binary instead of being done in ASCII. And there are, of course, a lot of proprietary protocols as well. There are so many different dimensions of compatibility that we have to deal with in terms of these platforms that it just makes the mind wobble. Fortunately, at the physical layer, everybody pretty much understands Bluetooth, they understand NFC, LTE, cellular, GSM cellular, they have 802.15.4, all these guys basically, they understand what those physical layers are. Then the data exchange sits on top of that. And when we start getting into the individual platforms, like Apple's HomeKit, for instance, Apple's HomeKit, they understand Bluetooth, Wi-Fi, or NFC. If it isn't in an iPhone, they don't do it, period. The way that HomeKit operates, Apple has a special chip that the manufacturer has to embed in their product. And in order to get access to the chip, they have to sign up for several million of these things. They have security you would not believe, in that if you call up a manufacturer and you say, hey, I'd like to get some information about your product, if you can't give them the secret password, I kid you not, the secret password, they will hang up on you. because you are obviously not plugged into HomeKit if you don't know what the secret password is. So if you're a consumer, that's a different thing. You just look for the logo. You just look for the HomeKit logo and it just works. If you're a manufacturer and you're trying to build products, then you have a product that works with Android and everybody else, and then you have a product that works with Apple. And you kind of have to make your decision and then spin a new PC board to incorporate their Apple identity chip. It does have end-to-end encryption for security. They do have some triggers based for geolocation, so if I'm driving home, it'll automatically trigger the air conditioners to then come on and start cooling the house down. But that proprietary silicon is an interesting problem. No real clear story at this point for access to the cloud. So they're not really making a coherent argument that says, yes, we're going to get you to the cloud and we're going to be able to do something with the cloud. It's almost always focused on local consumption. I've got my iPhone or my tablet, my iPad tablet, and I'm controlling the lights from the local house. I'm not really putting that out into the cloud and do anything significant with that. There is no Apple HomeKit app, remarkably enough. Apple has put together a series of APIs, and if you conform to the APIs, then you can talk to Siri, so that then you can command it using your voice and turn on the lights, make them blue, whatever, and all of that will, again, just work. Now, the thing about Apple's HomeKit is because it is a walled garden, it is proprietary, but it will work together because they don't have to worry about open standards. They can do whatever they want to do because it's Apple and you're going to buy into the Apple ecosystem. The other platforms, IoTivity. Now, we had some good presentations earlier today on IoTivity. The Open Connectivity Foundation, right, I'll get that right, and hosted by the Linux Foundation. This supports several of the different messaging protocols, of course, CoAP, MQTT, RESTful APIs. This is one of the few of the platforms that actually has small solutions. We talk about the Arduino kind of solutions. Those are AVR8s, those are 8-bit processors. This is one of the few of any of the platforms that really even try to address the edge. They do service discovery with MDNS and UPnP. By the way, for those of you who are familiar with all the security problems with UPnP, the version that they're implementing here is version 2, and it supposedly solves a lot of the security issues with universal plug and play. So hopefully it does in fact do all that. I know a couple of people that are on the UPnP standards committee, and I have every reason to believe they're telling me the truth. So that bodes well for the discovery piece of it. There is a certification process, and again, a lot of these things, when we talk about the consortiums and the foundations, they're really interested in branding. They want to make sure that everybody understands the brand. And if you see the Thread logo or you see the IoTivity logo, then you know that it's going to work with all the other devices that have the same logo. And that's a key piece. So when you look at what happens here, if you want a membership, an OCF, then it's $350K a year for a diamond membership. You want a gold membership, that's $2K a year. They have a $1K a year one for universities. Fortunately, you, to be able to use IoTivity, don't have to be a member of the Open Consortium, the Open Connectivity Foundation. But if you want to get your product certified, that's different. Now you can experiment with IoTivity. Great, they love you to experiment, and it's fantastic for doing that. But if you actually try to be a manufacturer and build something on top of it, now you got to get through the certification process. And that's going to cost you some money. Allseen Alliance, I'll join. This, again, developed by Qualcomm, originally founded by Qualcomm. They have over 200 companies as members. It's about the same number of members that they have in the IoTivity, the Open Connectivity Foundation. All join, it was interesting when you have Qualcomm as one of the founding members for Allseen, and then Qualcomm joined the Thread group. Really? So my founding member now joined the opposition? Obviously, they're in it to sell silicon. So you understand it from their perspective. They're there to make money, and you can't fault them for that. But it does kind of shake people's, confidence when the major founders kind of just start playing all sides at all the time. But this is one of the ones that Microsoft supports. So it will have a considerable number of adherents. And again, it's all about the logo. If you see the logo, then you know it'll be compatible with everything else. So that's a plus. We'll have a certification process and a design for Allseen logo program. And again, it's that whole idea of the industry trying to make sure they protect their intellectual property, but making sure that it's intercompatible. And that's kind of the key thing that Apple doesn't have to worry about, because it's just Apple. In the case of this, we have many, many different manufacturers all trying to come together at once. Of course, Allseen presents, it understands RESTful, it understands XMPP and MQTT, sits on top of the same sorts of physical spaces, so really not much of an issue in terms of the physical compatibility. Now it becomes the issues of the layer 4 and above, where a lot of these things start to get into their incompatibilities amongst themselves. The thread group, this is the one that was formed in 2014. It's a 501c. We do have, again, it's open to everybody who can afford to join. Sponsors are $100K a year. The issue with the thread group, and this is one of the frustrating things that I've had when I've tried to work with thread group pieces, they will sell you a thread group development kit, but they won't give you the stack. It's like, so why did you have me buy this $500 development kit if I can't get the stack? You go, well, you have to be a member of such and such. Well, okay, you should have told me that before I bought the development kit. All right, so it gets to be a little frustrating. Thread Group is starting to come out with more information. Again, they're an industry group. They're an industry trade association. They're trying to protect their IP. There's a whole bunch of websites and copyrights and trademarks and logos and all of that sort of business is what you get when you buy into being a member of the Thread Group. Their standard, they sit on top of IEEE 802.15.4. They do use 6LoWPAN for the most part, so that's an IPv6 compatible environment. It does have IP header compression. So with the IP header compression, you can actually get it down to like 7 bytes required to go outside of your network and be routed across the internet with a capital I. That's a pretty big thing when you have IEEE 802.15.4 has a maximum of 128 bytes in the actual frame, actually 127 in the frame. So if you think about IPv6, IPv6 has 40 bytes for the header alone. So if you don't do header compression, you're not going to have a whole lot of payload left over if you're trying to do that. Their security, they're using DTLS, datagram transfer layer security. They are sitting in the 2.4 gigahertz ISM band. They don't want to get into radio issues. The 2.4 gigahertz ISM band goes worldwide. You don't have to have a license to use it. So it means you can produce a product here in the US and have it work in Japan, have it work in Europe, that kind of stuff. So there's lots of other platforms. It's really a question of how much you want to research. When you, of course, the Eclipse Foundation has their own stuff. When we get into the industrial side, now this is where we start seeing some major players. You have, for instance, the building in the Frankfurt Airport is the largest building in Europe, and it has 80,000 sensors in the building. How do you provision 80,000 sensors? How do you take control of 80,000 sensors? How do you secure 80,000 sensors? That's an interesting set of problems. And there's a whole bunch of manufacturers that are in this space. Of course, ThingWorx, they have MQTT, DDS, REST, etc. Kind of the real claim to fame here is they have a rapid application development payload. It's kind of a dashboard kind of thing that you can then kind of drag and drop and get access to your data. They have IBM's Bluemix, that's another one, MQTT, RESTful, and other APIs. They use JNode, for instance. They understand Node, the JavaScript interface. Their platforms, they're free for up to 20 devices, and then they start charging you based on how many devices you actually have in the platform. They work with PubNub. PubNub is another platform. They are focused on data connectivity. So they have one data center, up to 1,000 devices, and 150 million messages, basically $1,000 a month. So this is, again, their team with Bluemix and several others to try and get more services out there. Verizon just came online with their one called ThingSpace. Again, they are the telephone company, and what they're trying to do is get you to use LTE as your communications path. And if they can get you to use enough LTE, they'll make money on the backside of that for the communications piece. But this is a brand new environment. They do have an extent dev kits. They use BeagleBone Blacks and Raspberry Pis. Again, trying to buy into the low end of that market to try and convince people to try it out. If they can then try it out in a home kind of do-it-yourself environment, maybe they will bring that in as engineers into an actual manufactured environment. Xively, another one. This one, they have a real problem with their identity. They used to be called Patube, then they were called Cosm. Now they're a division of LogMeIn. They keep changing their name. I don't know exactly what's going to happen with those folks. They use a message broker and RESTful APIs. There's Ethereos, yet another company. They are a subsidiary of Digi, the people who make the XB radio interfaces. Again, all these guys, they're focused on selling you disk storage and data storage. That's where they make their money, is the monthly recurring revenue of the data storage. So we have industrial Internet of Things and IoT. There's no shortage of offerings, and that's kind of the big problem. Everybody's got a platform. You're looking to see which platform is going to solve your problem. Fortunately, from the technical perspective, everybody speaks Wi-Fi, everybody speaks 802.15.4, Bluetooth, NFC. So the physical radios, pretty much everybody speaks. Most of them speak some significant subset of MQTT, RESTful, CoAP, or one of those types of messaging protocols. Then the real value add for a lot of these platforms is layer 4 and up. How do they then present an API to a user application that can then take advantage of all the services that they have on the bottom side? And then if you're in the industrial side, they're all about how can I make revenue from either the communications or the data storage or the data scientists to do the analysis. That's where they're going to make their money. So that's it. You do have issues, of course. There are lots of closed source implementations. We haven't really talked much about them except for Apple's HomeKit. They will probably interoperate more smoothly because they are a closed source solution and they can control the entire IP. But you got vendor lock-in. Once you buy into it, you're pretty much there and you're not going to get out. So it's entirely up to you what ones you want to pursue. But personally, as an open source guy, I'm all in favor of those ones that have Linux Foundation governance. They're pushing the open standards. Even the thread group has a lot of open standards, but until such time as they actually open it up so you can see what they're doing, then they're just as closed source as any of these other guys. So it is kind of a disappointment. But in any case, I'm almost out of time here. Any questions? Anyone still awake? Yes? Yes, these have already been uploaded. So the Linux Foundation, I sent them to the Linux Foundation last week. So they're already up there. Okay? That's it. Thank you very much.